In the S phase of the cell cycle, we talked about DNA replication and transcription occurring simultaneously. They're similar processes, but they're a little bit different. I'm going to start by talking about replication and then point out where transcription is different. There are 7 steps in DNA replication. Step 1 is where initiator proteins bind to DNA, telling DNA it's time to start replicating. Step 2, helicase cuts the hydrogen bonds that connect the nucleic bases. When helicase begins unwinding the DNA in the replication fork, it's gonna create a lot more tension down the line on both sides of the DNA. That added tension is also going to have to be relieved for the DNA to not just wind itself back together. When I get my hair braided, sometimes I have to hold the roots to relieve the tension while the braider is pulling at the rest of my hair. In the same way, topoisomerase creates cuts on the DNA to prevent extra tension. Step 3, primase is going to create RNA transcript for DNA replication to begin. Soon after, polymerase is going to come in and replace that RNA with DNA nucleotides. Because of the way they're set up, RNA is less stable than DNA, but DNA is going to take longer to make. So it's efficient for the cell to start with RNA to give DNA time to add on, but to be able to keep going on. Because both strands of DNA are going to be replicated, there are 2 different ways replication occurs. We're going to focus first on the leading strand, and we will come back to the lagging strand. On the leading strand, replication occurs fluidly. There's no stops needed. So once the primase has created the first little primer of RNA, it doesn't need to add any more primers. It can create bonds continuously. Because DNA is so long, there's going to be multiple origins of replication or multiple places where replication is occurring at the same time. So when one segment of replicated DNA meets the beginning of another segment, ligase is going to come and bind both of those segments together to create a continuous strand of DNA. On the lagging strand, because the DNA is replicating in the opposite direction, the bonds that DNA polymerase is going to be making are going to be happening the opposite direction of the direction replication is going to occur, which creates fragments. Each of those fragments is going to have to be bound together, similar to how each replicated strand has to be bound together on the leading strand. Each fragment has to be bound together on the lagging strand, also using ligase. To prevent the DNA from degrading when the nuclear envelope is removed, do you remember what phase of the cell cycle that happens in? Telomerase is going to tag the ends or add the nucleotides TTA-GGG to the end of the chromosomes. If degradation occurs, it doesn't occur of the important genetic material. Make it to be ready to be removed from the parent copy. When scientists were first studying DNA, they didn't start with human cells. They started with bacterial cells, most commonly E. coli. So the first discovery of polymerase function was in a prokaryotic organism. It got called DNA polymerase 1. Because it was the first discovery, it was the most basic function of DNA polymerase. Later, they realized there was another polymerase called DNA polymerase 3, which worked slower but made fewer mistakes. The difference between DNA polymerases 1 and 3 is that DNA 1 works faster, but it makes more mistakes, whereas DNA 3 has the ability to go back and fix the mistakes that it makes as it works, which means it works slower. How is it fixing those mistakes that it's making? Something called 3 to 5' exonuclease activity. When scientists refer to eukaryotic polymerases, they use Greek letters. So we've got polymerase alpha, beta, etc. Prokaryotic polymerases, Roman numerals. Eukaryotic polymerases, Greek letters. Thank you, science. There are 3 major differences between DNA replication and transcription. First, you can only create a transcript that is 5' to 3', which means you can only use a template that was 3' to 5'. Secondly, transcription factors are needed to begin transcription. Initiation factors are needed to begin DNA replication. And third, because we're making RNA, we're using an RNA polymerase, not a DNA polymerase. Prokaryotic organisms have a real basic ability to do transcription, so they only have one RNA polymerase. Humans have multiple types of RNA polymerases, so those are given Roman numerals. So there's RNA polymerase 1, which is human, but DNA polymerase 1 is a prokaryotic or bacterial organism. Thank you, science.